These two graphs, where m is a constant, are plotted on the same set of axes and they don't meet. What's the complete range of possible values of m? So let's treat it like were going to meet. So I'm going to set the y's equal x squared plus 5x plus 6 equals mx minus 3. This is now a quadratic, but I know there's no solutions. So x squared plus 5 minus mx, I've just minus mx and then factorized out the x, plus 9 equals 0. And for no solutions, no real solutions, we're going to have the discriminant less than 0. That's b squared minus 4ac. So 5 minus m squared minus 4 times 1 times 9 is going to be less than 0. 5m squared minus, well, it's 36, but I can write it as 6 squared less than 0. And you could expand this out and solve it like a normal quadratic, but actually, this is a difference of two squares. A squared minus b squared is a plus b, a minus b. So I'm going to go straight for that. This is my a and this is my b. So I will get 5 minus m plus 6, that's 11 minus m, multiplied by 5 minus m minus 6. That will become minus 1 minus m is less than 0. This will have roots 11, and here it will be minus 1. I've got minus m and minus m is actually going to be a happy quadratic, so it's going to go through 11 minus 1. It's going to look a bit like this. I want to know where it's lower than 0, so it's in between these values here. Therefore, it's minus 1 to 11. The answer is going to be A. Alternative ways to do this question, you could say that 5 minus m squared is less than 36. Now, you've got to be really careful square rooting here, because you can't just square root. But if the square is between less than 36, then without the square, it must be between minus 6 and 6. So that's another way to do this question. And then you could take it one bit at a time. You could take this one here and get m is less than 11. You could take this bit here and get minus m is less than 1 times through by minus 1. M is greater than minus 1. Both of these have to be true. We get the same answer. Thirdly, it's actually how they do it in some work solutions I've seen, but I think completing square is going to be the best way. You could expand the bracket out. So it would be 25 plus m squared minus 10m minus 36 less than 0. M squared minus 10m minus 11 less than 0. M minus 11, m plus 1 less than 0. And again, you get 11 and minus 1 as the roots. You'd end up drawing the same graph and do it from there.